Okay, we're going to talk about limits. This is extremely important topic, okay? Everything about calculus is limits. It gets pretty deep as you go along through calculus 1 and calculus 2, and maybe even some of you will take calculus 3, okay? The material gets very deep, and it's very easy to forget that you're actually doing limits. But the truth is, every single thing you will ever learn in calculus can be traced back to a limit of some sort. Okay, so this is extremely important. Now, I'm going to write here okay, what is the limit of f of x as x approaches a? That's a question that we're going to try to get our heads wrapped around. Okay, we're not going to answer that in technical details today. We're just going to get the idea. Okay, and just so that you understand here, it says, what is the limit of f of x as x approaches a? You might say, as x approaches a what? No, that's not what I mean. I mean that a right here is a number. Okay. All right, and f is some function. I'll go ahead and write that also. So you have a function, and you have a number, okay? And you're saying, what does it mean to say the limit of that function as the variable approaches this number that you have? Okay? So I want to give you the idea. Again, this is not going to be a highly technical definition. It's just going to be the idea. That's what I'm going to give you today. All right, so first of all, let me tell you how we write this. Okay, we write LIM is abbreviation for limit. Limit of what? F of x. Okay. As what? As x approaches a. So we write underneath the LIM, we write x arrow a. That means as x approaches a. Okay? Most of the time, I'll write in cursive because it's faster, and I'll just write something. It'll look, well, that's kind of sloppy. Let me do better than that, okay? Like that usually, okay? But if I'm trying to make it look really neat, then I'll print it instead of cursive. Okay, so what is that? Well, I'm going to tell you right now what it is, okay? It is the value, or if you prefer, you could say the word number. Value and number are interchangeable. It is the value that f of x gets arbitrarily close to as x gets arbitrarily close to a. Whoops. I'm going to say the value a, since I used that terminology value earlier in the sentence. Okay? Now, I want you to remember, and this is something you should know from pre-calculus or college algebra. Okay, let me say something really quickly about that. Many, many times this semester, I'm going to mention something and say, this is something that you should have learned in pre-calculus or college algebra. Okay, just to save time, I will use pre-calculus / college algebra as interchangeable terms. Okay, some of you took pre-calculus and some of you instead took college algebra and then trigonometry. Okay, but you know, just to save time, I'll sometimes say you should know this from pre-calculus. Okay, if you took college algebra, then that means you should know it from college algebra. Okay, or I'll say you should know this from trigonometry. If you took pre-calculus instead, then that means you should know it from pre-calculus. Okay, all right, so from pre-calculus you should know this, that f of x, what is that? That is the y values. Okay, you need to remember that. Like, for instance, if I say f of 2 equals 5, then that means when the x value is 2, the y value is 5. And so you would get the point 2, 5. Okay, that's something that you should know from pre-calculus. All right, so here is something that people will oftentimes get confused. All right, they might say, okay, so if you want to know what is f of x going to get close to when x gets close to a, then why don't you just plug in a? Okay, so in other words, here's the question that people sometimes ask. Isn't this just f of a? Okay, and the answer is no, it is not. Not necessarily. I mean, sometimes it might be, but it certainly doesn't mean f of a. Okay, if someone asks you what's the limit of f as x approaches a, and if you say, oh, that means f of a, then that means that person who says that has totally misunderstood the idea of limits. Okay, because the limit of f of x as x approaches a has nothing to do with f of a. Although sometimes they might come out to be the same number, they are actually totally different things. Okay? So the answer there is no for that question. And let me show you why. Okay, I'm going to write a function here. Let's write f of x equals, I'm going to do a piecewise defined function. You should have seen those before. Let's say f of x equals x squared plus 2 if x is less than 0. And f of x equals 1/3 x plus 2 if x is greater than 0. And f of x equals 5 if x equals 0. Okay, let's look at a graph of what that function looks like. Okay, I'm going to put some xy axis in here. Okay, so let's graph that function. If x is negative, then I get x squared plus 2. So here, I better put some marks on here. Let's do 1, 2, 3, 4, 5. Okay, and so that the negative x-axis is going to look like this. Well, I shouldn't say the negative x-axis looks like that, but f of x looks like that. The graph of f of x looks like that when x is negative. Okay. Whoops, I did not mean to do that. Sorry. Okay. When x is positive, I have a line that looks like this. Roughly, the slope might be slightly off. Let me look at that here. I think that slope's pretty close to 1/3. And when x equals 0, f of x is 5. So there's a point sitting right there by itself. Okay, which means what about down here? It means that there must be a hole right there. So that's what the graph of our function looks like. Okay, that's our function f. Okay, so let me ask you a question. Let's figure out the limit of f of x as x approaches 0. Okay, we're just going to use the graph, that's all, just by looking at the graph. So, as x is approaching 0 from this side, what is happening to the graph? The graph is coming down here and approaching. Oh, it stopped drawing. Okay, now I don't know what the heck happened entirely. Okay, here we are. Okay, so let's do this. I will use this pink thing here. Okay, the graph is coming down along here, right? As x is approaching 0. In other words, as x is approaching 0 from the left-hand side, then the y values are approaching right there, which is what? The value 2, right? Now, let's look at the other side. As x approaches 0 from this side, the graph is coming down here and is approaching that same y value, isn't it? So just looking at the picture alone, I'll show you how to actually do the calculations. But right now, all we're doing is just looking at the graph. Wouldn't you say that the limit of f of x as x approaches 0 appears to be 2? Do you agree with that? As the x values approach 0, the y values are approaching 2. Okay? Do they ever get to 2? No, they don't. There's actually a hole there. They never actually reach 2. But that's okay, because I'm talking about x approaching 0. I'm not saying that x is actually reaching 0. And that's super important. When you're doing limits and you say as x approaches a, that means you let x get arbitrarily close to a. It does not mean you're letting x reach a. Okay? All right. Now, let's look at f of 0. What's f of 0 for this example? Well, look what it says up there. Or look at the picture that I drew. F of 0 equals 5, doesn't it? So, when x approaches 0, f of x approaches 2. But when x reaches 0, f of x is actually 5. Are those two numbers the same? No, not at all, are they? Of course not. 2 is not equal to 5. So you see, it's very, very important for you to understand that this thing right here, the limit of f of x as x approaches 0, means something totally different than f of 0. They mean two totally different things. Okay? Now, sometimes they might happen to come out to be the same number, but they mean two totally different things. I'm going to write that down because it's so important. Okay? The limit, I'm going to write this in green. The limit of f of x as x approaches a and f of a mean two totally different things. If I just slide that over, I can finish this sentence here. Give me 1 second here. I hope, oh, I'm just right at the edge of the screen, aren't I? What I can see on my computer is not necessarily the same as what you can see in the recording, so I have to make sure I don't go too far off the edge. Okay, so that's very important. Okay, this one here this is what happens when x approaches a, not when x reaches a. See, two different things. Okay, and this one is what happens when x reaches a. Okay? Two different things. All right. Now, let's maybe go back to this same example. Okay, I'm going to go back up here to where I wrote down this function. Okay, let's look back at that. And let's just look again at the limit of that function as x approaches 2. How did I find this value right there? Do you remember? I was just looking at the graph. But let me ask you a question though. What if I did not have the graph? Or what if I had the graph, but it wasn't a very well-drawn graph? Maybe somebody was just scribbling the graph. You know, you should never trust the graph, right? The graph is a useful tool, but you should always base your answers on the mathematical stuff that you're given. Okay? You can't always rely on the graph. Although a lot of times we do rely on the graph, but what's important is you should be able to back up your conclusion with calculations. So let me show you how could we find this just by using those equations up there, not the graph. So I'm going to erase the graph entirely here. It's okay for you to remember that the limit as x approached 0 came out to be 2. It's okay for you to remember that, but I'm going to show you here how can you use calculations to get that answer. Okay, so here's what you can do. You can do a table of values, which might seem kind of juvenile to you. You might say, oh my goodness, we did that in like, 7th grade. Haven't we progressed beyond that? But don't worry. We're just starting out here. Okay, so here's what I want to do. I want to show you how I would figure this out. And by the way, this is how we approximate the limit. This is not going to be the very technical way of doing it. We are going to get an approximation that will lead us to conclude that the limit must be 2. Okay, so here's what we're going to do. Now, remember that we want to worry about x approaching 0. Okay, I don't care what happens when x equals 0, but nonetheless I'm going to go ahead and write down 0, but maybe I'll do it in a different color like gray, because this is not really what I'm concerned with. I'm concerned with x getting close to 0. Okay, but just because I feel like it, I'm going to go ahead and write down 0, 5 in my table of values. Okay, now let's put down x values that are getting closer and closer to 0, and let's go from both sides, from the positive side and the negative side. Okay, so how about if we do this? I'm going to write down, I'll just do 3, okay, 3 numbers that are negative that are getting progressively closer to 0. So maybe I'll do negative 0.1. That's pretty close to 0 already, right? But I can get a lot closer. What about negative 0.01 and negative 0.001? Those are 3 numbers that are approaching 0, right? From what side? From the left side. The negative numbers are on the left of 0, right? Let's plug those into our function and see what we get. So because they're negative, I should be using that equation, right? So negative 0.1 squared plus 2. What do we get? We get 2.01. Whoops, wrong color. 2.01. When I plug in negative 0.1 as my x value, I get a y value of 2.01. Okay, now let's plug in negative 0.01, and I get a y value of, oh, I hate it when that happens, I get a y value of 2.001. And when I plug in negative 0.001 into the function, I get a y value of 2.000001. Okay? All right, now let's flip to the other side, the positive numbers, and let's write down some positive numbers that are approaching 0, like 0.1, 0.01, 0.001. Okay, I think that's probably good enough. Okay, so those numbers are positive, which means I should be looking here. So I should be using this equation for f of x. Okay, so I'm going to take 1/3 times 0.1 and then add 2, and here's what I get. 2.0 and then 3 repeating. Okay, now let's take 0.01 times 1/3 and then add 2, and I get 2.00 and then 3 repeating. Now let's take 0.001 and plug it into the function. So it gets multiplied times 1/3 and then add 2, and I get 2.000 and then 3 repeating. Okay, so here's what I want you to look at. Okay, as x approaches 0 from either side, that's very important, as x approaches 0, look at the y values, and what do you notice? They appear to be getting closer and closer to the number 2, right? Don't say, oh no, they look like they're getting closer to the number 5. No, they don't, do they? Look at these numbers. Look at that, and that, and that. Do those numbers look like they're getting close to the number 5? They look like they're getting closer to the number 2, don't they? But that's only from one side. Look at the other side. Look at that number, and then that number, and then that number. You see, as x is approaching 0, it looks to me like f of x is approaching 2. Even though f of 0 is 5, but when I say limit as x approaches 0, then I do not care what happens at 0. I only care what happens when you get close to 0. Okay? You could even just leave that off of the table entirely. So I would say from that table, I would say it looks like the limit of f of x as x approaches 0 equals 2. That's what it looks like. Okay? Now you might ask this, and this is actually a very reasonable question. You might say, well, that's not good enough to say it looks like 2. We need to figure out if it is 2. And you're right, we do, but that's going to take us a few days. Okay? All we're doing right now is just looking at the table of values, and yes, it is true, we're sort of guessing. We're guessing that the limit is 2. Okay, because that's what it looks like from the table of values. Or when we had the graph, that's what it looked like in the graph. Okay? I'll even add on here in parentheses, even though f of 0 is not 2, it's 5. Okay? All right, so that's what I would like you to be able to do. All right? We're just going to do a few more examples. So the next example I'd like to look at is, let's look at this function. Okay, we can get rid of this stuff here now. Here's another example. If f of x equals sine of x over x, what is the limit of f of x as x approaches, we're going to do 0 again. Okay, as x approaches 0. That's what we're going to do. Let's answer that question. Now, I just want to put this out here. I could have just said this. I could have just said, what is the limit of sine of x over x as x approaches 0? That's another way of writing the same question. That would have been a lot shorter. It's just not the way I happen to write it, that's all. Okay, so let's figure that out. I'm going to do a table of values. X, f of x. Okay, as x approaches 0. So I'll go ahead and throw 0 in there, but here's the thing. What's f of 0? Look at it. That would be the sine of 0 over 0, which is 0 over 0, which does not exist, right? Non-existent. Or you could say undefined. There is no such thing as f of 0. Okay, but that's okay because that's not what the question's asking. The question's asking, what does f approach when x approaches 0? Okay, so again, let's just pick some numbers. There's no right or wrong numbers to pick. You can pick whatever numbers you want. Pick a few negative numbers that are approaching 0 and a few positive numbers that are approaching 0. It's very common to use the ones that I used on the previous example. People will oftentimes take negative 0.1, negative 0.01, and negative 0.001. There's some negative numbers that are approaching 0. And then on the positive side, we take 0.1, 0.01, 0.001. Okay. Just take those 6 numbers. You can do more if you want, okay, but I think 6 is usually pretty good. Just take those 6 numbers and plug them into our function, okay. So I'm going to calculate the sine of negative 0.1. Okay, you can't see this, but I'm typing this in to a calculator, and that's why I'm going a little bit slow. Okay, so I have the sine of negative 0.1, and then I'm going to divide that. Shoot, I think I made a mistake. Just a second. You know what? I'm going to pause for just a minute, and I'm going to get a better calculator than what I'm using. Okay, so I'm just going to pause, and you probably won't even notice this. I'll be right back. Okay, I'm back. You probably did not even notice that. All right, so let's plug in these numbers here. Okay, I'm going to plug in this guy right there, okay, into f. So sine of negative 0.1 divided by negative 0.1, and here's what I'm seeing on the screen. I'm getting 0.998334. How many decimal places do we need to write down? Well, I don't know. There's no rule about that. Just write down what you think is a good idea. You can do more than that if you want, but 6 decimal places is probably pretty good. Okay. Now let's plug in negative 0.01. So that's sine of negative 0.01 divided by negative 0.01, and we get point. Okay, I'm seeing here 9999, 4 nines, 83. Okay. Plug in negative 0.001 and I get 999999, and keeps going after that. It's actually an 8 next. It's not 9 forever. Okay. All right, so there we go. Now let's plug in the positive numbers that we picked there. 0.1, f of 0.1, I get 0.998334, just like way up at the top. F of 0.01, sorry, we get 0.999983 again. Oh, and I accidentally erased something there. There we go. And f of 0.001 is 0.999999, and then an 833 after that, but I'm going to stop right there. Okay. Now, there's no such thing as f of 0. You see that? But that's okay. That's not what I'm asking about. I'm asking about what happens as x approaches 0. So let's look over here, and I mean, maybe we'll disagree with this, but it looks to me like those numbers are approaching 1. Wouldn't you agree with that? So I would say it looks like the limit of sine of x over x as x approaches 0 equals 1. Okay? Even though sine of 0 over 0 is undefined. Okay? All right, one more, and then I'm going to stop because I can see the length of this video and I don't want it to go too long, so we'll just do one more. Okay? Let's do I'm going to write the question this way. Approximate, because that's all we're doing right now. We're just approximating. That's why I kept writing for the answers. I kept writing, it looks like the answer is this. Okay, because I'm just approximating. Technically, these two answers that I wrote there could be wrong. But don't worry, they're not wrong. Those are the correct limits. But all I'm saying is that we're just using table of values right now. Okay, and so all we're really doing is getting an idea of what we think the limit is. Okay, so here's the question. Approximate the limit of x squared minus x minus 6 over 6x squared minus 19x plus 3 as x approaches 3. Okay, so let's do a table of values. There's x. And I know I didn't give this function a name, did I? So, I mean, I could write f of x. I'm not going to mark anybody wrong if they write f of x here. But technically, I never said that that function is called f. So I suppose I better just write x squared minus x minus 6 over 6x squared minus 19x plus 3. If you want to write f of x, that's fine. Like I said, I'm not going to complain about that. Okay, so we're doing as x approaches 3, right? So let's think of some numbers that approach 3 from the right. Think about a number line. And here's the number 3 right there on the number line. Okay, what are some numbers on the, oh, I said the right a second ago, but I meant to do the left first. What are some numbers that approach 3 from the left? How about 2.9 and 2.99 and 2.999? How about using those numbers? Okay. 2.9, 2.99, 2.999. Those are definitely getting close to 3. Okay. Now let's go some numbers from the other side that are approaching 3. So how about 3.1, 3.01, 3.001. Let's use those numbers. Okay. All right, so let's do that. There's a calculator problem right now. I'm going to show you how to do it later without a calculator, but right now where we're standing at this point is that this would be a calculator problem. Okay. Take 2.9 and plug it into here, and you would get 0.298780. That's 6 decimal places. I'm going to stop there. Okay. Now take 2.99 and plug it into here. And you're going to get 0.294569. Okay. Now the next one, 2.999, plug it into there, and you should get something like this, 0.294163. And I'll cut it off there. Okay? And now let's do these 3. And I'll just write down what you get for those 3. Okay? For 3.1, when you plug it in, you're going to get something like this, 0.289773, ... 3.01 is going to give you 0.293669. And 3.001 gives us 0.294073. So let's look at that table of values. As x approaches 3, what does it look like the y values are approaching? And I could totally see different people saying different things here. Okay, some people might say it looks like it's approaching 0.3, and that would actually be a reasonable answer. After all, the question just says approximate the limit. So if you said, I approximate that the limit is 3, I would say, okay, that's a good approximation. Somebody else might say, it looks to me like it's approaching the number 0.294. That would also be a good approximation. Okay? There's no one correct answer here because it says approximate. So different people are going to have different approximations depending upon how close they're trying to get. Okay? So if you said the limit as x approaches 3 equals 3, I would say good. Okay? If somebody else said, I would disagree, and I would say that the limit looks to me like, somebody might say, oh, I'm sorry, I wrote 3, didn't I? But I meant to say 0.3. So earlier when I said 3, I meant to say 0.3. Sorry about that. So if somebody said 0.3, I'd say good, that's a good answer. If somebody else said, well, I don't think it's quite 0.3, I think it's just 0.29, then I would say that's better. Okay? And somebody else might say, well, I can do better than both of those. I think the answer is .294. And I would say that's even better than the one before. Those are all good answers. Okay? I think that might have gone off the screen. Let me move this over there. Okay, I want to make sure you guys can see that. Those are all acceptable answers. Okay? If this was a homework problem, I would accept all 3 of those. Okay? Just for fun, I'll tell you what the actual answer is. So those 3 are approximations because that's what the question says. Find an approximation. So those are okay. All right, but this is just for your information for the future, okay? And I don't know how many lectures it's going to take, but in a few lectures, you're going to be able to do this problem and get an exact answer instead of an approximation. And what you would find is you would find that the exact answer is actually, I worked this out earlier and I believe I got 5/17. I think that's what I got. Let me think here. 5 over... Yeah, that looks right. Okay? So that's the exact answer, but I'm going to erase that now. I just put that there just for your information. I'm going to erase it because I don't want you to think that you should be able to get that answer because we haven't covered that yet. I haven't taught you how to get the exact answer. I've only told you how to get an approximation, and any of these approximations would be fine. Okay? So that's the idea of a limit. I'm going to stop there. That's enough for one day. And if you have any questions, then that's what the Zoom discussions are going to be for. You watch this video and write down any questions. And if you do have a question, pay attention to when it is in the video so that when you ask me, you can say, at the mark of 5 minutes and 17 seconds, you said this and I need more help on that. Okay, so that I can know exactly where it is that you had a question. All right? Okay, I'll talk to you guys later.